So here we're going to look at one-fold rotoinversion. The way that is symbolized is as a bar 1. This is to distinguish it from a simple one-fold rotational axis. So a one-fold rotational axis, we don't usually talk much about this one because it is boring, or for a more technical term, we say that it is trivial. It's trivial because it doesn't do anything. So let's take a motif, let's say a comma, and we rotate it 360 degrees. We get the same motif back, so we don't get anything new. We just keep generating the same thing in the same position over and over and over again. So that's the trivial case, and we're not going to worry too much about that. But some interesting things happen when we combine the one-fold rotational axis with inversion. So we invert something through a point. And we're going to use this example here using a figure from Klein and Dutrow. They have an original motif here, in this case a comma. They're going to rotate it 360 degrees, which is, again, that boring, trivial case, which just gives us this same comma back. So nothing interesting there. But then we're going to invert it through a point. Let's call it I for an inversion point there, where the tail of the comma will go through the point and end up there, and then the body of the comma will go through the point and end up there. So we get another comma down here. Now, if we take that comma that we've generated here, which is clearly distinct from the first one, and rotate it 360 degrees and then invert it back, then we're back to the original one. So that means we're done. Once we come back to our original motif, we've generated all the possible motifs that we're going to get out of this operation. Now, again, just to be clear, this does not have to be a comma or a hand or a tree. It could be anything. Any object you like, and then for mineralogy and crystallography, usually it's an atom or maybe a cluster of atoms that this kind of operation is going to be occurring on.